So this is the 2014 Junior Cert Higher Level Paper 1 and we're looking at question number 8. The table shows the height in meters of a ball at various times after being kicked into the air. Part 1 is the pattern of heights in the table linear, quadratic or exponential, and explain your answer. So in the table here we are going up in half seconds. So every half second the height is measured, and here we have our height. So if we're going to check is the pattern of heights linear, we're going to see is there a common first difference. So as we move from 0.3 to 3.4, that is a jump of 3.1, positive 3.1. Then from 3.4 to 5.7, that's a jump of 2.3. From 5.7 up to 7.2, that's a jump. If you want to find the jump, you can subtract the 5.7 from 7.2, but that gives us a jump of 1.5. So we can see it's not linear because the first difference is not the same. I'm going to continue this on anyway. 0.7. Again, these are all positive. There we go. We're going back down now, so minus 0.1, and from 7.8 down to 6.9 is a jump of negative 0.9. Okay, so to check then, it's not linear, so we've established that because this common difference, the number is not constant. So to check if it's quadratic, we're going to do the second difference. So to go from 3.1 to 2.3, well, that's a jump down of 0.8, so negative 0.8. To go from 2.3 to 1.5, again, just subtract 1.5, take away the 2.3, and again, this gives us minus 0.8. So we can see now we've got a common second difference here. We'll just keep checking though. 0.7 minus 1.5 gives us minus 0.8. And what you find then is that actually the second difference is constant. Second difference is minus 0.8. So we know then that it's quadratic. So the answer is quadratic. And the explanation or the reason for that is that the first differences are not the same. But the second differences are. Okay. Part 2 then says estimate the height of the ball after 3.5 seconds. Okay, so if we're going up in half seconds, 3.5 seconds would be the next. If you were to continue the table on another one, it would be the next column. So we know then that we're going up in jumps of negative 0.8 for the second difference. So if I continue that, from minus 0.9, we take a jump of minus 0.8, that will give me minus 1.7. And if I go up a level again, from 6.9, if I take a jump of minus 1.7, it brings me to 5.2. So that's going to be the height of the ball after 3.5 seconds, 5.2 meters. Okay, and then finally, part 3 says estimate the total time the ball spends in the air and justify your answer. Okay, well, the total time the ball spends in the air, we can see that the height is increasing as we go along until it gets to 7.9. It starts to decrease again. So we want to see, when does it get down to 0? When is the height 0? Because that would mean it's on the ground. So we can continue on the pattern till we get towards 0. So if you remember, we had if I go another minus 0.8 here, that would bring me to minus 2.5 here, and 5.2 minus 2.5 gives me 2.7. So that would be after 4 seconds, 2.7. And if we go another time, then another minus 0.8 from minus 2.5 would give me minus 3.3, and then minus 3.3, if we go from the 2.7, we go minus 3.3 from 2.7, that gives us a value of minus 0.6. So that would be the next column on, which would be 4.5 seconds, and we're into a negative height after 4.5 seconds. So an estimate then would be just before 4.5 seconds. It's just below at 4.5 seconds. So we might say something like, for our estimate, 4.4 seconds. And the justification for that would be the height is 0 just before 4.5 seconds. So 4.4, something like that would suffice as your estimated answer, because it does say estimate. So that's the end of part 3 and the end of question 8.